Okay, so I just stumbled across this model that matches names in kanji with their katakana readings, and it's a real game changer.
Wait, seriously. That's fascinating. How does it actually determine if the names match?
So it uses a scoring system from 0 to 100 to indicate the match quality. Higher scores mean better matches.
That's pretty cool. But I wonder what happens if names are very similar but not identical.
Great point, it seems like that could be tricky. It might confuse names with similar kanji.
Exactly. And does it only work for Japanese names, or can it handle foreign names too?
It can handle foreign names. There's a model that matches Romaji with katakana, which is super handy.
That's unexpected. It sounds like a really versatile tool, but how does it ensure accuracy?
It uses a combination of dictionary data and machine learning, particularly a transformer model.
Transformers, like the ones used in natural language processing, that's promising.
Right, they break down the names into individual characters for better matching.
Interesting approach, but what about the data quality? Is it all reliable?
The model pulls from diverse sources like Wikipedia and various Japanese dictionaries.
That's a solid range. But how does it deal with dialectal differences in names?
Good question. I think the model's effectiveness might vary depending on specific regional names.
That makes sense. A name like Yamada could have different readings depending on context.
Exactly, plus some kanji characters have multiple readings. It gets complicated.
So it seems like there's a lot of nuance here. Does it provide explanations for its matches?
It outputs the most likely katakana readings but doesn't really explain why.
That's a bit of a limitation, isn't it? Users might want to understand the rationale.
Definitely, context matters a lot in language, so some transparency would help.
I wonder if future versions might incorporate user feedback to improve accuracy.
That's an interesting idea. Real-time corrections from users could enhance its learning.
Plus, it could help it adapt to new names as they become popular.
Totally, language is always evolving, so a dynamic model would be ideal.
Speaking of evolution, how does this model compare to traditional methods of name matching?
Traditional methods often rely on static dictionaries, making them less flexible.
That's a significant difference. This model must be way faster too, right?
Absolutely, the algorithm can process inputs much quicker than manual checks.
That efficiency could really benefit things like immigration or registration processes.
For sure, it could streamline a lot of bureaucratic tasks.
But what if the model gets it wrong? That could lead to some big issues.
True errors could cause misunderstandings or misidentifications.
That's a serious risk. Maybe built-in review mechanisms could help mitigate that.
That would definitely be a step in the right direction, a safety net for users.
I like that idea. It's all about balancing tech efficiency with human oversight.
Exactly, it's fascinating how technology can both simplify and complicate processes.
And the implications reach into areas like cultural identity and representation.
Right names are so tied to identity, so accuracy is crucial.
So if it misidentifies a name, it could potentially misrepresent someone's identity.
Absolutely, it's a reminder that technology needs to tread carefully with personal data.
So in the end, what are your thoughts? Is this model a step forward?
I think it's promising, but it needs careful implementation and constant improvement.
Totally agree. It's exciting, but there are definitely things to watch out for.
And keeping the human element in the loop is just as important.
Exactly. Balancing innovation with responsibility is the key here.
Let's keep an eye on how this technology evolves. It's sure to be interesting.
Absolutely, I can't wait to see where it goes. This has been a great discussion.